Next, jury stability test. Let the characteristic polynomial of a closed loop system is an z power n plus an minus 1 z power n minus 1 plus an minus 2 z power n minus 2 n minus 2 plus etc. plus a1 plus a0. This is the characteristic polynomial of a closed loop digital system. For that, we have to test the stability. In continuous domain, we'll check by using Routh array. Routh array, the first column of Routh array should not have any sign change. That way we'll test. In the same way here, this jury stability test, what here we will do is, we have to form the jury's array. For that, we have to start with A0, A0, A1, A2, etc. An minus 1, An. And we have to reverse the second row is this An minus 1, An minus 2, etc. A1, A0. Similarly, we can find the next row, that is B row, that is B0, B1, B2, etc. Bn minus 1. It will end with n minus 1, one short of A row. Similarly, Bn minus 1, Bn minus 2, etc. B0. Similarly, we can find C row, that is C0, C1, C2, etc. Cn minus 2 and Cn minus 2, Cn minus 3, etc. C0. So this way it will go on like that. But what is B0? B0 equal to determinant of A0, An, A0. That is, we have to consider this first column and the last column. Determinant of first column and the last column is B0. What is B1? B1 equal to the same first column, no change in the first column. But we have to consider last but one column. That is A n minus 1, A1 we have to consider. What is B2? B2 equal to the same, no change in first column. Second column is last but 2. This column we have to consider. That is an minus 2, A2. Like that, we have to find. So we have to find n minus 1 up to Bn minus 1 we have to find. What is C0? C0 we have to find from B row. That is B0, Bn minus 1. And this and this we have to consider to find C0. Bn minus 1, B0. And C1 equal to the same way. No change in the first column. Bn minus 1 and Bn minus 1, B0. Like that we have to consider. So we have to proceed this till only 2 elements are in the last row. Till then we have to proceed. Then we have to test for the stability. The condition for stability are 2 conditions are there. One is called necessary condition. Necessary conditions. The necessary conditions are f of 0 must be greater than 0 and minus 1 to the power n f of minus 1 also should be greater than 0. These are the two necessary conditions. What are the sufficient conditions? Sufficient conditions. Sufficient conditions are modulus of A naught must be less than modulus of an. From the first row, we have to consider. We have to consider this element and this element. Modulus of A naught must be less than modulus of an. From second row onwards, modulus of B naught must be greater than modulus of Bn minus 1. And the modulus of C naught must be greater than Cn minus 2. Like that, etc. Then D naught must be greater than, modulus of D naught must be greater than D of n minus 3, etc. If it satisfies all these conditions, till the last row becomes only 2 elements, if it satisfies all these conditions, then the system is stable. When, what is the difference between necessary condition and sufficient condition? For example, getting pass in +2 examination is a necessary condition to join in any college, but it is not sufficient. You have to get good marks. So sufficient condition is like that. If sufficient condition is satisfied, no need to check the necessary condition. If passed, then only we'll check for marks. So that's why first, if it fails in the necessary condition, no need to check for sufficient condition. But if you check directly sufficient condition, no need to check the necessary condition. That's all. Now let us solve some sums on this. Now let us check the stability of a system whose characteristic equation is f of z equal to 5z square minus 2z plus 2 equal to 0. Let us check first the necessary condition. F of 0 equal to 2, that is greater than 0. Minus 1 to the power n, that is 2 here, n equal to 2 in this case. F of minus 1, if you substitute minus 1 for z, you will get 5. For this, if you put minus 1, you will get plus 2, that is equal to 9. That is also greater than 0. Therefore, it satisfies the necessary condition. That's why this system may or may not be stable. There is no guarantee that it is stable. May or may not be stable. So we have to check the sufficient condition. For that, we have to form the array. So we have to start with A naught, 2, minus 2, 5. This is A naught, this is An. Then we have to reverse that. 5 minus 2, 2. So we have to form B row. If you form the B row, what you will get? B naught equal to modulus of 2, 5, 5, 2, 4 minus 25, minus 21. And what is B1? B1 equal to modulus of 2, 5, minus 2, minus 2. Minus 4, minus of minus 10, plus 6. Therefore, B row is 6 minus 20. Only 2 elements. That's why we have to stop here. No need to proceed further. If you go, only 1 element will come. That's why there is no need to go further. So now we have to check the conditions. What is the first condition? Sufficient condition. Modulus of A naught must be less than modulus of An. What is modulus of A naught? 2 is less than modulus of 5. First condition is satisfied. The second condition is modulus of B naught must be greater than modulus of Bn minus 1. That is B naught equal to 21 minus 21. That should be greater than modulus of 6. Yes, that is also satisfied. Therefore, the given system is stable. That's all. Try yourself. Here, f of z equal to z cube minus 0.2 z square minus 0.25 z plus 0.5 equal to 0. This is the characteristic polynomial. Another sum, f of z equal to z power 4 minus 1.72 z cube plus 1.04 z square minus 0.268 z plus 0.2 equal to 0. Here it's A naught, A row is 1, sorry, start with 0.5 A naught, 0.5 minus 0.25 minus 0.21. So we have to reverse that 1 minus 0.2 minus 0.25, 0.5. Here modulus of A naught is less than modulus of AN. So it's satisfied. We have to find B naught and we have to check for B naught must be greater than Bn minus 1. So how many rows it will give? Next row will have 3 elements. So B will be there. C, 3 elements. That's why we have to find here only 2 elements will be there. Therefore, up to C it will come. So we have to check the conditions. B naught must be greater than Bn minus 1 and C naught must be greater than Bcn minus 2, like that. So for this, it will go up to D. Z power 4, that's why it will go up to D. For that, we have to check the D naught must be greater than Dn minus 3, like that. So you solve this yourself.